Hi everyone, this is coming to you from Education for All. We are looking at the last problem, problem number 3. Is it okay? Yeah. Problem number 3. Problem number 3 reads f of x equals ax squared, where a is a constant. Prove from first principles that f prime x is equals to 2x. First principles of calculus is this idea you see here. This is the idea of first principle. The limits. M means gradient. So the gradient of a curve is equal to the limit of the function of that curve plus the small displacement it makes minus the function itself divided by h, as that displacement tends to 0, tends to decrease, approaching to 0. So that is the first principle. IFA is the fundamental principle of calculus. We also call it the first principles of calculus. So now we are to prove that ax squared, where a is a constant means this is a number. A number, it could be any number. It could be 1, 2, 3, 4, minus 8, 50, whatever, any number. Prove that f prime x is 2ax. F prime, when you see f prime, this prime here is the same as gradient, is the same as derivative. So if you don't want to write f prime x, you write m. If you don't want to write m, you write dy, dx. They are all the same. This is m, it's gradients. This is f prime x. These are all the same. So it depends. So the way the problem is given to you, then you know which one to use, especially these two. These two here, f prime x and dy dx. It depends to the situation. Sometimes it's better to use this solving a problem. Sometimes, depending on the nature of the problem, it's better to use this notation. This is not dy over dx. It's not a fraction. This is a notation, dy dx. If you see dy over dx, it's like a fraction, 5 over 7. But it's not like that. This is a notation. It's just representing something. It's not a fraction. So all these three, and if you want, you can include derivative and gradients. So all these 4, 1, 2, 3, 4, in fact 5, they are all the same. When they say dy dx, you can even call it m, you can even call it f prime x, you can call it derivative if you want, you can call it the gradient of the graph if you want. So they are the same. Yeah. That being said, now let's go to the question. It says, prove that from first principles, prove from first principle that f of f prime x is 2ax. So now we are using f prime x instead of m. M we have here, but now it's f prime x, but it's the same thing here. So we're having f prime x is equals to the limit as h tends to 0, f of x plus h. So you're having 2a. Now that your x plus h, but mind you, your x here is squared. So x plus h, you have to square as well. S moves by h. So if you square it in the function, you have to square the h as well. Minus a x squared all over h. I've used the first principle to represent this problem like this. This is what you get, because we're asked to use from first principle. So this is what you get. This is a constant. That's why it's outside the bracket. It's not, it's a placeholder. It's holding the place of a number. That number we don't know. It's not given to us. So it's a number. Although you see it's like A, it's still telling us here A is a constant. Constant means it's a number. Right? So now what we need to do here is just to expand this function we have here, x plus h all raised to the power of 2. So let's expand it before we bring it here. X tends to 0. Let's expand this one. I'm expanding x plus h squared. This will give us x squared plus 2hx plus h squared. But then we have 2a. So this 2ax plus h squared. So we are just multiplying by 2a. So this 2a, you will get here 2ax squared plus, you multiply this by 2a, so you'll get in 4ahx, and you are multiplying this by 2a, so you'll get in plus 2ah squared. So this is what you get when you expand this whole thing. This is what you get. So I'll now put it here as 2a x squared plus 4a hx plus h squared, then minus ax squared. Minus, where does the 2 come from? I shouldn't have 2. Sorry, I shouldn't have 2. I shouldn't have, no 2. No 2. This is remains 2. I shouldn't have 2 here. It's a. Sorry. I thought there is a 2. So I'll just multiply it by a. So you'll get ax squared minus plus 2ahx plus ah squared. There is no 2. Just getting confused about these two. So there is where is it? Where are we now? We're having wow, ax squared. I need to ax squared plus 2ahx plus ah squared. Then I'm bringing this minus now. Minus ax squared all over h. I hope it's clear from this point. Yeah? So that is what you get. So now, what can we see from this equation? We can see that ax squared cancels ax squared. So what is left here is f prime of x equals to the limit as h approaches 0. We will have here 2a hx plus h squared all over h. This is what is left. So still, we know we can be able to factorize h. There is h here, there is 2h here, and we have h at the bottom. So if we factorize h, we'll have h 2ax plus ah all over h. Oh, I forgot to write the limit. The limit the limit as h tends to 0, right? So you can see this h will cancel this h. So what is left? You now have 2ax plus ah. But when this approaches to 0, this h approaches to 0. When it's very small, very, very small, so it's almost becomes negligible in this equation. You just ignore it. So which means this part here will go to 0. So what is left is 2ax. So you have 2ax. So which is proven. It's 2ax. The moment this approaches to 0, that is what this h means. Approaches to 0, this is 2ax. This principle, what we are doing now, you might not be able to see the importance of it, this principle here. But if you go back and you try to understand how it came about, you'll start to see the importance of it. Then when you start to solve advanced problems in physics and maths, then you will know what this principle means. For now, we are doing this elementary stuff. You will not actually see what this means. Yeah. So that is it. We have proven that f of f prime x is 2ax. Thank you for watching, and bye-bye.